Welcome to True Projects. In this video, we are going to explain about a project titled Distracted Driver Detection using the Deep Learning. Presently, the prevalence of high-resolution images has significantly increased across various visual applications. One such application is image surveillance, where multiple high-resolution cameras are strategically positioned at different locations. This facilitates the collaborative effort in identifying and tracking the moving target, enabling the advanced analysis like behavior recognition and even potential intention prediction. Moreover, in emotional computation, high-resolution cameras capture the subtle changes in real time, offering the valuable insight into a person's emotion and enhancing the security measure. The capability to acquire and store the large volume of high-resolution images has become more feasible with technological advancements. Currently, the identification of unusual driving behavior using the image analysis has become increasingly popular for ensuring the driver and passenger safety and advancing the autonomous driving technology. Recent progress in deep learning methods has significantly improved this challenging task by harnessing the powerful deep learning models, generalizing the capability, and leveraging the vast image dataset for training. This study focused on deep learning fusion techniques, introducing the three innovative fusion models inspired by dense-net architecture. Additionally, other deep learning models like VGG16 and MobileNet are also explored. These findings underscore the potential of deep learning and fusion models in effectively addressing the image-based abnormal driver behavior detection, promoting the road safety and shaping the future of the driving application. These are the basic requirements that are needed to build this project. The software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirement: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps that we need to discuss. First one is importing the libraries. This project begins with importing the essential Python libraries such as NumPy, Pandas, TensorFlow. NumPy is used for numerical operation, Pandas for data manipulation, Matplotlib for data visualization, and Keras for building and training the deep learning model. And the second one is exploring the dataset. In this, the dataset consists of images captured while drivers are driving, and each image is associated with a specific class representing different distracted driving behavior, like of testing, talking on the phone, eating, and many more. The exploratory data analysis is performed to understand the dataset structure, visualize the sample images, and examine the class distribution. And the third one is image scaling and processing. To prepare the images for model training, they undergo the pre-processing steps like resizing, normalization, and possibly the augmentation to increase the dataset's diversity and improve the model ability to generalize the different scenarios. And the fourth one is split the training and testing data. The dataset is divided into the two subsets, the training data and the testing data. The training data is used to train the deep learning model, while the testing data is kept separate to evaluate the model performance on the unseen images. This step prevents overfitting and ensures the model's generalization. And the fifth one is building the model. Here, the three popular deep learning models are chosen for building the distracted driver detection system, that are VGG16, MobileNet V2, dense-net. And the first one is VGG16. It is a deep convolutional neural network that was introduced by Visual, and it is characterized by its simple and the uniform architecture consisting of 16 layers, including the 13 convolutional layers and 3 fully connected layers. It is known for ability to extract the detailed feature from images, making it effective for the tasks such as object recognition and image classification. For the distracted driver detection project, VGG16 is used as the base model and its fully connected layers can be replaced by the fine-tuner to the specific classification task. And the second one is MobileNet V2. It is a lightweight and efficient CNN architecture designed for mobile and embedded devices. It is optimized application with limited computational resources, making it suitable for real-time application like distracted driver detection. It achieves a balance between the model size and accuracy by using depth-wise separable convolution and inverted residual. Despite its efficiency, MobileNet V2 can still achieve the high accuracy and various image recognition tasks. And the third one is DenseNet. It's a CNN architecture that emphasizes the feature reuse and promotes the dense connection between the layers. It connects each layer to every other layer in the feed-forward fashion, facilitating the flow of information throughout the network. DenseNet reduces the vanishing gradient problem and encourages the feature reuse, leading to the better training efficiency and improved performance, especially on of the smaller data sets. And the sixth one is training the model. The selected deep learning models are trained on the pre-processed training data. During the training, the models adjust the weights and parameters to learn the patterns and features that distinguish between the different distracted driving behavior. And then the seventh one is user gives the input. The Flash web framework is utilized to create a user-friendly web interface where the user can upload the input image and they want to analyze for the distracted driver behavior. And the eighth one is the given input is pre-processed for prediction. When the user uploads or inputs an image through the Flash web interface, the input image undergoes the same processing step as of the training data to align with the model requirements. And the ninth one is trained model is used for prediction. The pre-processed input image is fed into the trained deep learning model for the prediction. Each model predicts the probability of the input image belonging to the different class representing of various distracted driving behavior. And the last one is final outcome is displayed. The model's prediction to the input image are presented to the user through the Flash web interface. The final outcome indicates the likelihood of the driver being engaged in specific distracted driving behavior. This information can be used to awareness about the dangerous driving habits and promote the safer driving practices. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of different files within it. The images folder containing of the training and testing of different images within the folder, and the output folder containing of the training and testing data, and the static folder containing of the CSS, JS, images, fonts, and the bootstrap files within it. And the template folder containing of the HTML document as of home, index, notebook, result, sign in and sign out. Upload folder containing of the images that is used for testing the model performance. And the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file as a Jupyter notebook which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the signup.db as a file appear to be the database file used to store the user information. To execute the project, first we need to copy this address path and open the Anaconda prompt. And we need to change the disk location as of F because our code folder is present in the F. And then here write the command cd space and paste the address of the code folder and click on enter button. After this, we need to write another command as python space app.py. Here, this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after that, click on enter button. By this, running the app.py file, the Flask framework will host the application locally at the default address as of like this. And we need to copy this local link and provided by the framework and paste it on any web browser. And I prefer to use of Chrome. That's why I'm opening the Chrome and pasting this local link and then click on enter button. And here this home page contains of sign in and sign up button. By clicking upon the sign up button, here we get an registration page containing of the various necessary details that is used to create a new account. But my account is already registered, that's why I'm using the sign in button to enter the username and password as of admin. And then click on login button and click on OK button. Here the page is redirected in this form and then click on choose file button. By this, it's redirected to this upload folder containing of the images that are used for testing, and I'm selecting one image and then click on open button and then click on upload button. By this, it redirected to the another page and it detected as of suspicious activity testing left detected. In this way, we can detect the driver distraction, and by using the try again button, it redirected to the past page, and here we can choose another file and select any one of the image and then click on open button and then click on upload button. Here we can detect the suspicious activity talking on the phone. In this way, we can detect the driver distraction by using various deep learning models. And in conclusion, the current focus on the image-based abnormal driving behavior detection has grown significantly due to its crucial role in ensuring the driver's safety and its relevance in achieving the full automatic driving, particularly of autonomous driving as defined by the US Department Highway Traffic Safety Administration. This study introduced the three innovative fusion models based on the deep learning technique to address the task of image-based abnormal driving behavior detection. These novel models draw the inspiration from the widely recognized TenseNet architecture proposed in these recent years. In the term of technical aspects, these models prioritize the important design factor in modern deep learning includes the depth, width, and cardinality.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.